Here's an example to work out. Two vectors are given. V1 is 10 meters per second at an angle of 53.1 degrees, and V2 is given in components as a column vector. So the x component is -3 and the y component is 2. Let's add those two vectors. In order to do the components, we need to figure out what the first vector is. Oh, let me just write. So we want to find the sum V1 plus V2. We can go ahead and just call that V total for the total. So let's find the sum of V1 plus V2. I was saying we want to find V1 as components in order to add. So V1 is given as 10 meters per second at an angle of 53.1 degrees. Just to make a sketch of that, so that is our V1 is 10, and I want to find the components where that theta is equal to 53.1. I'm having trouble writing today. Theta is 53.1 degrees. So let's find the components of V1 so that we can add it. If we look over here, the x component is the adjacent side, so we know it's going to be the cosine. So the cosine of theta is Vx over V. Rearranging, we get Vx equals V cosine theta, which is our 10 meters per second times the cosine of 53.1 degrees. And that turns out to be, I'm just going to keep one sig fig here, that turns out to be about 6. And that's the first one, so V1x is 6 meters per second. Similarly, I can do the y component. The y component turns out to be, use the sine because this is the opposite side, V sine theta, 10 meters per second times the sine of 53.1 degrees. And that turns out to be about 8 meters per second. We can write that as a column vector. V1 vector is equal to 6 in the x slot and 8 in the y slot meters per second. Now we have both vectors written in components, and it's very easy to add them. We say that the sum V total is V1 vector plus V2 vector. And we can just replace each of those with our column vectors. This is the one we just worked out. And the V2 was given already in components. That was the -3 and the 2 meters per second. Then, just like in the previous slide, we can use the rows as an equation. So 6 minus 3 becomes the x component of the total. So 6 minus 3 is 3. And then we have 8 plus 2, which is 10 for the final. So we get that the final vector is 3 in the x and 10 in the y. If the problem doesn't tell you to write it in terms of magnitude and direction, you can leave it in components. Remember, you just need 2 pieces of information for a 2D vector, and the x and the y components are perfectly good. Let's draw a quick sketch to make sure this makes sense. So we have our 10 meters per second at an angle of 53. So that's a little bit hard to eyeball. It's all going to be above, it's all in the positive y, so I'll skip a little bit. So at an angle of 53, so that's just, I'm just eyeballing this one, 10 meters per second, and that's our theta of 53. The other, and of course, if I had an actual graph paper, we now know that it's 6 and 8, so I could count over 6 and count up 8. And then for the other one, it's already done for me, so it's -3 and then up 2. So it's about there. So that's my V1 vector, and this is about my V2 vector. And then remember that the rule is to put them tail to tip, and then you can add them. So if we imagine sliding this one up And again, I was just doing this by hand, so it's not it's not going to be perfect at all. But if we just do it that way, and then we try to go from the tail of the first one to the tip of the second one, then this should be V total. It's definitely in the first quadrant, so we at least got that part right. It has a magnitude of 10, and that looks, again, eyeballing it, looks similar to the length of the first one. Sorry, not a magnitude of 10, a y component of 10. So that distance should be about the same as the length of V1, because that was 10. And then it's over about 3, and again, this is just me eyeballing it, but it's not that far off. So this would be about half of my 6 and about half of my 6. So that looks reasonable. So there's one example of adding two vectors.